So today we will discuss non-muscular movement is a part of Unit 1, protection, support and movement. Actually, the non-muscular movement is mostly this type of movement takes place with the help of various structure. These structure include Pseudopodia, Cilia, and Flagella. These three principal structure, they are responsible for this non-muscular movement. They are called non-muscular movement because no muscles are involved in this case. So these three principal kinds of non-muscular movements are found. Movements by means of pseudopodia, movement by means of cilia, movement by means of flagella. These are cilia, numerous type of cilia. This is pseudopodia, this is flagella. As you know that pseudopodia, so this is a Greek word. Pseudo means false and podia means foot, false foot. And this pseudopodia is actually a temporary cytoplasmic projection. This is a temporary projection of the cytoplasm. That is why this is a temporary structure, and this is the extension of the cytoplasm. The main function of the pseudopodia is to provide locomotion. In second one, they also play important role in the collection of food. The locomotion or movement by means of pseudopodia is explained by theory which is known as Sol-Gel theory, and this is also called change of viscosity theory. This theory was proposed by Hyman in 1917. The theory is actually based on the reversible change of the protoplasm from sol to gel state. So here the conversion of two states from sol to gel state takes place. Actually, the amoeba consists of two. The cytoplasm consists of the outer one, which is known as the ectoplasm. This is the ectoplasm. The inner one, the endoplasm. The inner cytoplasm is called plasma-sol. Plasma-sol, because they consist of more fluid portion. This is why this is called plasma-sol. The outer cytoplasm or the ectoplasm is called plasma gel, and they are gel-like structure. Gel means that here the fluid are less; they are more jelly-like structure. So this is the plasma gel, which have more gel-like structure, and this is the plasma sol, which have more fluid-like structure. They consist of more fluid portion. According to this theory, the plasma gel is converted to plasma sol state. And why the conversion of plasma gel to plasma sol takes place when water is added to the organism. When water is added, then the plasma gel is converted into plasma sol, and plasma sol is converted into plasma gel, then water is released. So as you know that according to this theory, it is actually a reversible change, a change of two state from sol to gel state, and this takes place by the addition and removal of water. So plasma gel, when water is added, this plasma gel and the region of the plasma gel after the addition of water, the gel portion then contain more fluid. That is why that gel is converted into the sol region. And when water is released, the sol is again converted into the gel region. So plasma gel is converted into plasma sol when water is added, and plasma sol is converted into plasma gel when water is released. An amoeba is moving in this direction, like when gel transforms into fluid sol. So, and then the sol transform into gel state, then there is a little bit extension of the tip of the side of the pseudopodia. So here a little bit movement takes place. So the amoeba moves by means of pseudopodia and When water is added, the plasma gel transforms into plasma sol, and uh, plasma sol is converted into plasma gel when water is released with a little bit extension of the pseudopodia. You know that cilia and flagella, they have two important structures. Both the structure found outside the cell. Cilia, these are cilia, they are found outside the cell. This is flagella, they are also found outside the cell. Cilia are numerous, short-like. These are numerous, consist of many structure, short-like structure, and they found outside the cell. And flagella are one, they are found in pair, and they have long hair-like, web-like structure. Cilia are short hair-like structure, and flagella are long web-like structure. And function of both the cilia and flagella is to provide movement. As far as the structure of the cilia and flagella is concerned, internal structure of both cilia and flagella is the same. They consist of ring of microtubules. These are ring of microtubules, and these are wrapped or enclosed in the membrane, the plasma membrane. And there are 9 pairs of microtubules. These are 9 pair of microtubules, and there is along with a central pair microtubule. So structurally, both cilia and flagella are the same. The main difference between a cilium and flagella is their beating pattern. Both play important role in the moment, but their beating pattern is different from one another. A cilium beat asymmetrically with a fast power stroke in one direction. First it moves in one direction fast, followed by a slow recovery or backward movement during which the cilium bends as it returns to its original position. The cilia actually first it moves forward, the forward direction, moving fast forward direction, and then again they return slowly to its original position. So this back and front beating of the cilium is responsible for the movement of the flagella. And due to this back and front beating mechanism, they propel water parallel to the cilium. While flagellum beats symmetrically with a propeller-like motion, and their motion is just like a snake-like motion, undulation, so that here the water is propelled parallel to the line axis of the flagellum. So in case of long flagellum, the movement is actually takes place like a propeller type motion. So both cilia and flagella have same internal structure, but their movement or the beating pattern is different from one another. So these are the 3 types of non-muscular movement: the movement which takes place by means of pseudopodia, the movement which takes place by cilia and flagella. All are the non-muscular movement, because here no muscle are involved, therefore the movement is called non-muscular movement. Thank you.